we're going to go on and look at the entrance ticket. Now, some of these here might be a little bit unfamiliar, or it's been a little while since you've seen these. So once you get those turned in, we'll go on and close Chromebooks. Now, the first one, which of the following is the defining characteristics of a kite? And we do have four here. Now, a kite is a four-dimensional shape, or not four-dimensional, a four-sided shape with two sets of consecutive congruent sides. That's what we define a kite as. Now, could all four sides be the same? Well, yes, but the main definition is two sets of consecutive congruent sides. So, a kite has four congruent sides. Well, not all kites will have four congruent sides. Now, the opposite angles are going to be congruent. It is true that the angles between the non-congruent sides are going to be congruent, but the other two are not. So we're not going to have four congruent angles. The kite has congruent diagonals, well, no. A kite has one pair of parallel sides. That would actually be a rhombus, or not a rhombus, a trapezoid would have one set of parallel sides, so that really leaves us with B. A kite has perpendicular diagonals, and a kite would have perpendicular diagonals. So for one, it is B. Now for number 2, in the figure below, the measure of angle DBA is 55 degrees. The measure of DCB is 25 degrees. And the measure of angle ADB is 90 degrees. What's the measure of angle ADC? So we want to know that whole angle. Well, this triangle here, well, any triangle, the angles add up to be 180. I know that one of the angles is 90 and the other is 55. So we say 55 plus 90. 5 would be 145. And if we subtract that from 180, we get 5, because that would be 7, 10, 35 degrees. So that angle there is 35 degrees. Now you might be wondering why we would do that. Well, this bigger triangle here is still going to add together to be 180, so we can take 35 and 25, add those together and subtract it from 180. 0, carry the 1, 6. So if we subtract 60 from 180, we would actually get 120. My brain's trying to jump ahead. So this whole angle here is 120 degrees. Right. Because we're really looking at this triangle here, which is our ADB, and we actually can consider the other triangle ADC. And they're part of each other. Yes. Now the last one of the entrance ticket, in the figure below, A, B, D, and E are collinear. Collinear means that they are on the same line. They're all on the same line. Coplanar would be on the same what? Plane. Coplanar is on the same plane. Collinear is on the same line. BD, CD, and DE are all the same length, which they have denoted. And the angle measures of angle DCE is shown. DCE is shown as 35 degrees. What is the degree of angle ABC? Well, we know for certain it's going to be greater than 90 because it looks like it's greater than 90. And for the ACT, if it looks like it, it's most likely going to be that. So we do know that it is greater than 90 degrees and that there is 35. Now, what we know about this triangle over here is that it is isosceles because it has two congruent angles and the sides opposite congruent angles are the same. So if that's 35 degrees, it means this angle over here is 35 degrees. It also means that these three angles here add together to be 180. So we can say 35 plus 35 is 70. And if we subtract 70 from 180, we get 110. So that there would be 110 degrees. these two angles here add together to be 180 because they make a straight line, which means angle D here, this angle over here is 70. And the reason we say that is, again, because we have another isosceles triangle. These two angles are the same. Well, they all add together to be 180. Well, if that's 70, these two here have to add together to be what? 110, because that's how we got 70. And they're both going to be the same, so what we can do is take 110 divided by 2, which is 55. Okay. So that angle there is 55. This angle is, well, we're getting closer to the angle we want. That angle and 55 degrees make a straight line, so they add together to be 180. And if we subtract it from 180, we get 125. And at some point, I hit the next arrow to show the answer. Five, 125 degrees. Any questions on this here? Now, a lot of what we're doing today is talking about properties of triangles and angles and solving for interior and exterior angles of various shapes. Now, the first thing we're going to look at is this kind of quick check here. This isn't in your notes, but we still want to look at it. Now, the first one, what do we call this figure? Yeah, a triangle. It's a figure with 3 sides and 3 angles. The sum of the interior angles of any triangle is 180. Sum of the interior angles of any triangle is 180 degrees. Now, the next one we actually call an isosceles triangle. And we call it isosceles because we have 2 congruent sides. A triangle with 2 sides of equal length. The angles opposite the equal sides are also equal, because the angles opposite congruent sides are congruent. The sides that are opposite congruent angles are going to be congruent. It goes either way. The next one that we have is a right triangle. We call it a right triangle because it contains one right angle. And in our Euclidean geometry, any triangle, any right triangle can have one right angle. That's just by definition for Euclidean geometry, you can only have one right angle. If we talk about non-Euclidean geometry, we can actually have triangles with 3 right angles. And we could actually have a triangle with an angle greater than 180, but that's on spherical geometry, geometry on a sphere. The next one that we have is an equilateral, equiangular triangle, because equilateral means that it's a triangle with 3 equal sides, and the angles opposite those sides are all going to be 60 degrees. If it's equilateral, it means all 3 angles are 60 degrees. Well, since all 3 angles are 60 degrees, it's actually also equiangular, because if we have one, we have the other, which in case we just call it regular. A regular polygon is any polygon with all congruent sides and all congruent angles, which incidentally, and then it talks about interior angles. They're the angles that are inside the shape. I have a feeling the next one's going to be exterior angles. An angle outside a shape's perimeter, because they're on the outside. And the sum of the exterior angles of any polygon is, you all remember? 360. It's always 360 degrees. The sum of the exterior angles is always going to be 360. And when we talk about that here, because if we notice the exterior angles are all on the same side, they're all going to be in that same side, in the same face. Now, the next part is congruency. Angles and sides indicate size and measure, because we can talk about side, side angle, those different type of properties when we're talking about congruency. And we can also talk about congruency with these markers, because we'll use little hash marks to signal that sides are congruent. And we'll use little angle kind of markers inside to consider or kind of show that the angles are congruent. Now, a quadrilateral is any four-sided figure. On the wrong way. Four-sided figure types include trapezoids, parallelograms, rectangles, squares, rhombuses. Any of these are considered four-sided figures. When we talk about a square, we're talking not just about a four-sided figure, we're talking about a four-sided figure that has four right angles and four congruent sides. It's the most specific we can get. Quadrilateral is just any four-sided figure. And so once they start giving us these names, like trapezoids, parallelograms, rectangles, squares, all the properties of square are true. That it's going to have four right angles and four congruent sides. As soon as they tell us that, we know that that is true. Now, a trapezoid is a quadrilateral with one pair of parallel sides. Now, if we call it isosceles trapezoid, well, it's a trapezoid with one set of congruent sides. And the congruent sides are going to be the non-parallel sides. And the base angles are going to be congruent, and the angles between the parallel sides actually add up to be 180. Parallelogram, a quadrilateral whose opposite sides are parallel. Parallelogram has two sets of parallel sides. That's just by definition of a parallelogram. If it has four congruent sides, it's considered to be a rhombus with all equal sides. A diagonal is a line joining two opposite corners of a quadrilateral. It has to be opposite. A pentagon is a figure with five sides and five angles. Hexagon, figure with six sides and six angles. All right. And again, these are a lot of just the definitions of shapes. You probably remember them, you probably don't, here or there. And what we want to do with this here is really just finding out the angles for these missing lengths. So we're trying to find A, B, C, and D. And ever since y'all finished geometry, anytime we see two angles that make a straight line, we can assume they add together to be 180. So if I wanted to find the measure of angle A, well, A and 51 degrees add together to be 180. So we can take 180 and subtract 51 from it, which would give us 129 degrees. Because again, they make a straight line. If we wanted to find the measure of angle D, well, 78 in angle D, again, make a straight line. So we can take 180 and subtract 78 from it, which would give us 102. What can we do to find the measure of angle B? Well, these three angles here add together to be 180. So we can take 102 and add 51 to it, and then subtract it from 180. So this would give us 153. And we'd subtract 153 from 180, which will tell us that angle B is 27. And lastly, if we want to find angle C, we would subtract 27 from 180, or we can add up. Because I'm trying to get from 27 to 180. Well, 3 would get me from 27 to 30. 30 to 80, I would need 5 and a 1. You can just add up to it. So angle C would be 153. Yep. For some reason it did D first and then throw it away. So that's it there. In a triangle, each exterior angle is equal to the sum of the two interior angles farthest away. And what this is talking about is if we have a triangle like this here, and we have this angle here. I'll call this A, B, and C. And if you had me for geometry, we went over this. It's probably been at least a year or two, year longer. Any three angles in a triangle add up to be 180. That's been drilled in your head over and over and over again. So we're saying that A plus B plus C is equal to 180, yes? Well, I know any two angles that make a straight line add together to be 180 as well. Well, these two angles make a straight line. So we could also say that X plus A is equal to, let's go back to gold. Both of these are equal to 180, yes? So I could say that X plus A is equal to A plus B plus C. Those are the same A, yes? So if I subtract its length from both sides, cancel, cancel, telling me that the exterior angle is equal to B plus C. The exterior angle is equal to the sum of the opposite two interior angles. That's kind of nice. So whatever this measure is equal to the sum of these two here. If I know it's a triangle and I can find out what this angle is, what those two have to be, what the sum of them is anyways. And that's true for any figure, and they'll use this, especially on the ACT, because looking at this here, we can get to the missing angles. Because if I wanted to find V, W, Y, and X, if I had to find all of them, we could work our way through and get there. If they just ask us to find Y, angle Y, we could get there finding each one individually, but it's going to be a little bit faster to use the exterior angle theorem. The fact that these two angles here will add together to be 122. So we're really saying that Y plus 61 is 122 degrees. We can just subtract 61 from both sides, telling us Y is 61. Well, wait a minute, those two angles are the same, yes? If we look at the figure, what did it tell us? These two sides are the, so the angles opposite them have to be the same. The figure told us it. Now, if we want to find angle V, well, these two angles here add together to be 180. I mean, at this point here, we can do 180 minus 122 on the calculator to get an answer. Or if I look at this here, well, 8 plus 2 is 10. I'd carry the 1, which would turn this 2 into a 3. I'm trying to get to 8. I'm missing. I'd add 5 to it, which would pull it from a 3 to an 8. I already have the 1. I'm done. So it's just adding up. So that's 58. Well, we can subtract the other two from 180. 9, 7, which would give us 119. And tell us it's 61 because it's isosceles. So there's more than one way to get at a lot of these answers, especially on the ACT. But there's sometimes faster ways to get there if we recognize what the figure is. Two interior angles opposite the congruent sides of an isosceles triangle are congruent. Well, we kind of actually did all of this. Apparently I can zoom. Okay. We'll identify these shapes here and then we're done for today. Now, looking at this first one here, we do know that the two sides are 4, yes? So most likely, all 4 sides are going to be the same. Now, if this had been one of my geometry tests, and you put square, I would have to say no, because do we know anything about the angles? No. Do they look like right angles? Yes. So on the ACT, identify each shape. So this here would be a square. Because again, on the ACT, if it looks like it's a right angle, then it is a right angle. They're not going to be jerks like that there. They're just going to say that it is a square because it does have, these here tell us that we do have 4 congruent sides, and they look like right angles, so they are right angles. Now, this next one here, okay, since 2 sides are 4, the rest are going to be 4. But do we have right angles? No. And a shape with 4 congruent sides is a rhombus. But we do know that the opposite angles are going to be congruent, and the angles that are consecutive add up to be 180. So it works out that these two are going to be congruent, these two, and these add up to be 180. What would we say about the next one? Rectangle. And inside of a rectangle, we do have 4 right angles. The opposite sides are congruent. The diagonals are actually congruent to each other. What about the next one? Trapezoid. And it wouldn't be isosceles because the non-parallel sides are not congruent. And the last one. It's a parallelogram. The reason we can't say rhombus is because we have 7 and 3. Since those two side lengths are opposite or not the same, we'd have to go with parallelogram. Because we can say that those 2 sets of sides are parallel for sure, because they look like they're parallel. So for the ACT, that's good enough. Because really getting more in depth than that's going to take way too much time to really try to delve through definitions. And for a lot of the pictures, it's just too much information. But that's about it. That's all we're going to